Welcome to Mathematics Lecture Series, lecture number 12 on Applied Calculus Series, Theorems on Limit. Before the start of lecture, I request you kindly subscribe the channel and like the video. Observe this theorem, limit x tends to 0, sin x over x is equal to 1. So this is a theorem, this is a definition by which we solve the examples and problems of the limit. Using limit x tends to 0 sin x over x is equal to 1, we solve these four problems. Number one is limit x tends to 0 sin 3x over x. Limit x tends to 0, we itself multiply and divide with 3, so we will have sin 3x over 3 into 3. What about this limit x tends to 0 sin 3x over 3x? It is equal to 1 by using limit x tends to 0 sin x over x. So 1 into 3, it is equal to 3. Now problem number 2, limit x tends to 0 sin 3x over sin 4x. So we similarly limit x tends to 0, we multiply with 3x and divide, we multiply 3x and divide with 3x, and we multiply 4x divide with 4x. Then what about this? So we rearrange limit x tends to 0 sin 3x over 3x. Here we can apply limit x tends to 0 4x over sin 4x. Here we have x will be cancelled with x, so we will have 3 by 4. By using definition limit x tends to 0 sin x over x is equal to 1, this is equal to 1 and that one is also equal to 1, so we will have 3 by 4. Problem number 3, limit x tends to 0 1 minus cos x over x square. Limit x tends to 0 1 minus, by rationalization we multiply and divide 1 plus cos x 1 plus cos x. 1 minus cos x 1 plus cos x is equal to 1 minus cos square x, and here we have x square 1 over 1 plus cos x. So 1 minus cos square x is equal to sin square x, so we can write it sin x over square. Limit x tends to 0 1 over 1 plus cos. We can, by multiplication property, we can write a limit to separately to each function. Then by definition of limit x tends to sin x over x, it becomes 1 square. Limit x tends to 1 over 1 plus cos. Apply the limit, so 1 cos 0 is equal to 1, so we will have 1 by 2. Problem number 4, limit x tends to 0 1 minus cosine 5x 1 minus cosine 9x. Similarly 1 minus cosine 5x is equal to sine square 5x, and 1 minus cos 9x is equal to 2 sine square 9x by 2, and 1 minus cos 5 cosine 5 2 sine square 5x by 2. So we can write it sine 5x by 2 5x, we multiply with 5x by 2 and 5x by 2 whole square must be 5x by 2 whole square, 5x by 2 whole square. Limit x to 9x by 2, so we multiply and divide 9x by 2 whole square. So what about this, that is limit x tends to 0 sin 5x by 2. By the property limit x tends to 0 sin x over x is equal to 1, so it 1 square, and that one is also 1 square. Here 5x will be cancelled with x 2 by 2, and we have 5 over 9 whole square. So I haven't write here, but here understood 5x by 2 9x by 2 whole square. So we will have 5 square is 25, 9 square is 81. So we will have lost answer 25 over 81. This is a graph of sine x over x. This function is also a sinc function. Its graph is here. Its applications may have the in electrical, electronic, telecommunication and mechanical engineering disciplines. Observe that graph. Here if we approach from left side or right side, this graph gives us 1. So limit sine x over x, limit x tends to 0 is equal to 1. You can easily see if we approach from the right hand side to 0, we will have 1. Left hand side, then also we will have 1. So limit sine x over x is equal to 1 whenever x approaches to 0. In this lecture we have discussed limit sine x over x, by which we solve the problems. I request you kindly subscribe the channel and like the video. Thank you.